Hi there. We're going to do a calculation using scientific notation, and we're going to use that so that we can get an estimation for this without using a calculator. Not something that will probably be very useful to people, but it'd be interesting to see an application of scientific notation, and estimation is always a good skill to exercise. So this is going to begin by converting each of these numbers to scientific notation. So I've got 5.25 times 10 to the negative 1. Now if you're not very good with your scientific notation, I'll take a moment here with the last number, and I will take my time with it and talk about scientific notation a little bit. So what's at here? 2.25 times 10 to the first, right? So let me just double check each of these at this point. 5.25 times 10 to the negative 1, that would give me 0.525, so that's correct. 7.82 times 10 to the third would give me 7,820, correct. And 2.25 times 10 to the first would give me 22.5. So those are all correct. I'll do this last one, and I'll take a little bit of time with it. So I'm going to have this 0.00475, and I need to move the decimal point 1, 2, 3 to the right so that I can write this as 4.75 times 10 to a power. Now what power would I multiply this 4.75 by in order to have the original 0.00475? So hopefully it's clear that I need to multiply it by a negative value. I need the power to be negative so that the decimal place would move to the left. So hopefully you have that much of an understanding of powers of 10 and how it fits in to the scientific notation. So if I moved the decimal place 3 to the right, as I showed here, then that's going to use negative 3. And then if you wanted to check that, you could really punch this into a calculator. You could write it out as 4.75 over 10 to the third, and then 10 to the third is 1,000. You could do 4.75 over 1,000 on your calculator and see that this really does work. We really have converted this to a number times a power of 10 that matches the original number. So if you need more detail on scientific notation, you can ask your teacher for a little tutoring on that, or you can find another video. I don't have a video up for this at this point, but maybe I will in the future if enough people ask me. So here I've got times that's not where I'm at. I'm at the 0.004751. So that's times 4.75 times 10 to the negative third. All right, now we're going to address the part of this, the one significant digit part, because I haven't really helped myself out at this point, right? I kind of have with the tens. So I guess we could look at that part first and see how I've helped myself out with the tens. So I'm going to take down the numbers, 5.25 times 7.82, and the 2.25 times 4.75. Now these tens that we have here, 10 to the negative first and 10 to the third, 10 to the negative third, we're going to be able to combine all of these because they have a common base. So we're going to be able to use laws of exponents. So that's the usefulness of converting to scientific notation here, is that I've set myself up to use the laws of exponents with these powers of 10. So let's take it in a couple of steps here, or I'd like to do it in one step, and hopefully you can follow along. So I've got 10 to the negative first times 10 to the third. So that would be common base, add the exponents. So negative 1 plus 3 is 2. So let's just set that off to the side here, up on the right. So I've got 10 to the second all right? And then in the denominator, I've got this 10 to the first and 10 to the negative 3. So I'll take that up to the right, common base, add the exponents. That's going to be 10 to the negative 2. So we have 10 squared over 10 to the negative 2, and then that's a common base, and hopefully we know the law of exponents that tells us how we combine the exponents when there's division by a common base, right? So I'm going to subtract those exponents, and I'm ending up with 10 to the 4th, and that's in the numerator. So I'm going to go times 10 to the 4th here. All right, so you see how scientific notation, by getting powers of 10, that set me up for a calculation that helps simplify things a little bit. But I still have all these numbers over here, right, that I would just plug those into a calculator. But we are going to do this part here, one significant digit. So I'm going to convert all of these numbers down here, the 5.25, if you look down in the bottom left-hand corner, the 7.82, I'm going to convert all those to one significant digit. So let's do that. That's going to be, it's just rounding off, and I'm sure you know how to round off. 5.25 is 5, 7.82 is 8, 2.25 is 2, and 4.75 I'll round off to 5. And we'll keep the times 10 to the 4th. All right, we have a couple of things we can cancel here, or we have one, yeah, we have some things we can cancel, right? So we can go 5 and 5, we can go 2 with an 8, and that'll leave a 4. So if you can read the numbers here, what I've got left, see I've got 4 times 10 to the 4th. Now, hopefully it's not too big of a leap for you for when I say 10 to the 4th is 10,000, right? So that's 4 times 10,000, which is 40,000. Right, and then just a little interesting side note here. If I were to go back up here to the top, all right. So this original expression, if I had plugged that into a calculator, what would I get? Let's just look at that. I would have gotten 38,414.04. So we can see what we did with the estimation. The estimation got us 40,000. And down on the right, remember we got 40,000 down there on the right. And how does that compare to the actual value of 38,414? You know, it's an estimation. And it's a pretty good estimation, especially considering that we did it without a calculator. If I would have done this without a calculator, without using scientific notation, just think about how painstaking and tedious that calculation would have been. So I hope you've learned something about scientific notation, and that you might be able to do a calculation like this for yourself. Thanks for listening.